Hi everyone, thank you for being here today. I'm Zora Chung, Rejual's co-founder and CFO. Our mission is to maximize the value of electric vehicle batteries by streamlining its life cycle from cradle to cradle. We do this through our fast battery diagnostic platform that performs health checks in minutes without sacrificing accuracy. Next slide, please. Over the next 15 minutes, I'll provide a brief company overview, highlight the obstacles we're seeing in repurposing used electric vehicle or EV batteries, and our solution to that problem. As part of the overview of our solution, I'll walk through 2 case studies where we tested used electric truck and then forklift batteries, as well as other benefits of our technology and technique. From there, I'll cover what's next on our roadmap, and I'll wrap up with how you can take the first step to work with us. Next slide, please. We were founded over 4 years ago after my technical co-founder, Steven, personally experienced the frustration of modeling a battery's health. When he realized how inefficient the industry standard was, he decided to use his expertise in power electronics to set a new standard by making better data and modeling tools available. Since then, we've raised almost $5 million in grant funding to support the research and deployment of our technology. $3 million of which comes from the California Energy Commission and funds a project for Rejual to repurpose used EV batteries into a stationary application to provide backup power for 2 commercial and industrial buildings. We have an amazing team of engineers, also known as the Rejualigans, and we're supported by our advisors who have extensive experience in the automotive, battery, energy, and technology industries. Next slide, please. While I'm sure most of you are as excited as we are about the increasing adoption of EVs, the reality is in 4 years, we'll need to figure out what to do with the 3.4 million battery packs retiring from EVs. We're already starting to see batteries pile up at customer sites. The cost to ship and recycle these batteries costs upwards of $1,000 per pack. So instead, they are looking to repurpose. But the next challenge for them is how to get the battery's state of health. You need that for 2 reasons. First, prospective buyers of used batteries will want to know its capacity and remaining lifetime. And second, you need to make sure the batteries you have will work for the intended application. We like to joke that used batteries are like a box of chocolates. You never know what you're going to get. This means you need to test every single battery. Next slide, please. Some of you may know the current process to test batteries is to cycle it, which is to fully charge the battery and then measure how long it takes to completely drain it. In order to do this, you need specialized equipment, labor, and a lot of time. The screen shows 3 different types of equipment we have in our lab to perform this type of testing: a cell, module, and pack cycler. They have different specifications and each cost tens of thousands of dollars. For automotive grade batteries, getting 1 data point can take between 6 to 10 hours. Right now, the only standard that exists on repurposing batteries is UL 1974, which outlines a test procedure to qualify used EV batteries for stationary applications. If you want to certify to UL 1974, it will take you 40 hours per battery non-stop. Steven, our CEO, is a standards technical panel member on UL 1974, and he's definitely shared the feedback, as well as others, that this isn't really a reasonable expectation as it is prohibitively expensive. Next slide, please. We'd like to introduce a more viable solution where we can get results in seconds or minutes without sacrificing accuracy. We leverage a technique called electrochemical impedance spectroscopy, or EIS. I won't go into too much detail here, but essentially we inject a sine wave into the batteries and measure the response. The test is fast and non-invasive. It is also seen as the gold standard to characterize batteries, but its use has been limited to lab testing at the cell level. Steven was able to leverage his expertise to scale up the technology to be able to grade entire battery modules. Next slide. Our solution comprises proprietary hardware, software, and algorithms. Our hardware connects to the battery terminals to perform the measurement and inject the sine waves. Our software does the data processing to create our aging algorithms. The data is plotted on a Nyquist plot, and from there we can provide the state of health in amp hours or kilowatt hours. Next slide. We've proven we can work with a variety of battery types. We've graded over 1 megawatt hour of new and used batteries from different chemistries, form factors, and configurations. I'd like to take the next few minutes to walk you through 2 case studies. In both cases, we had no historical information and we performed traditional cycling as the benchmark for accuracy. Next slide. As part of the CEC project, we graded over 500 battery modules from 9 retired electric trucks. We immediately rejected a handful due to physical defects. Of those remaining, we used 80% as the training set and 20% as the test set. The test set represents real-world samples. They're batteries that the model has never seen before. The purpose is to validate how well the model behaves with new data. In this instance, we followed a UL 1974 test procedure as best we could and then added 2 of our own EIS tests. We performed a 30-second test and a 5-minute test. We have some interesting findings to share. First, it took us only 50 battery samples for the model to start producing accuracy within 3% of the benchmark. We found our 5-minute test produced accuracy within 2% and our 30-second test within 3.5%. To determine if a battery can be repurposed, this is definitely more than good enough. Next slide, please. Now, onto our second case study with forklift batteries. Here we had 110 used cells and 5 new cells as a reference. Again, we followed UL 1974 as best we could and used cycling as a baseline, which took about 4 hours per cell, and then we added our own EIS tests. Again, we performed 2 tests, this time a 1-second test and a 5-minute test. We wanted to test how much accuracy we would sacrifice for speed. We realized it wasn't much of a sacrifice as we were able to get within 2% accuracy. On the screen, we've graphed the distribution of the batteries by amp hours from cycling on the left and Rejoule's EIS test on the right. You can probably barely tell the difference. The colors signify if the batteries were new or used, and if they were used, what comments they had on them. For instance, the ones in red were flagged as bad, but that was because they were part of a bad pack, but most of the cells were still above 75% state of health. From this analysis, we recommended the customer delay their replacement schedules since the cells were not very degraded. We're doing the same process now for some retired bus batteries. Please reach out to us if you have battery characterization or grading needs. We can perform a similar study on your batteries. Next slide, please. Aside from a fast and non-invasive test, we've done some preliminary studies to show our EIS methodology has a few other benefits as well. First, we can perform our testing when the battery is under load, basically when it's in use, like during charging. The second capability is using EIS to perform internal temperature estimation. The EIS measurement changes a lot with temperature, so we can leverage that by using rapid EIS as an internal temperature sensor. In comparison, temperature sensors are currently external to the battery module, so it takes time to actually identify a temperature rise, like when a cell is getting overused and starts to overheat, or worse, the onset of thermal runaway, also known as a battery fire. Combining those 2 capabilities, we mostly performed our test at a constant current, which is directly applicable to charging, but we also did some preliminary analysis when running an urban dynamometer driving schedule, or UDDS cycle. We were still able to get a good reading of the internal temperature. The URL on the screen will take you to our technical paper that details our work and findings. We also have a pre-recorded presentation shared during a conference hosted by the Electrochemical Society. I'll have more details on how to get a hold of that recording at the end of my presentation. Next slide, please. We're in the midst of scaling up our technology from testing modules to entire packs. This will allow us to move up the value chain by testing batteries before they are removed from the EV. This data can be used to more accurately assess the residual value of the EV. Here we're seeing similar challenges where the lack of information on the battery's health and history is making buyers hesitant to buy used. This can also be used to perform regular health checks during maintenance. This way, when there is an issue, our diagnostic platform can tell you whether there is truly a battery issue versus a wiring issue, or if you simply need to look elsewhere. Lastly, when the vehicle reaches end of life, our tool can qualify the battery for repurposing. In an ideal scenario, you can ship the batteries directly to its second life application without having to store them yourself. We're targeting to have our first prototype ready by the end of this year. We are seeking OEM partners now, and we can create a first product that can work with your latest EV model. Next slide, please. To get involved, please start by reaching out to us for a consultation. Let us know what are the key problems and applications you want to address. At this point, it's helpful for us to know any details you can share on the battery and vehicle specifications, as well as your timing and budget constraints. From there, we can design a proof of concept project to fit your needs. We'll set and agree upon target performance metrics. This ensures we can demonstrate short-term benefits while setting up the foundation to create value in the longer term. We ironically refer to our business model as GaaS, Grading as a Service. While our product comprises hardware and software, we believe the value we bring is in the grading algorithms. So each facility would have its own set of hardware and software tools that would require its own monthly subscription. We would set up the hardware and software at each site, provide training to your staff, and of course, provide support to ensure things run smoothly. One way to get in touch is by emailing us at info@rejuelenergy.com, which is at the bottom of the screen. Next slide, please. We'll also be attending 2 conferences in the next month. The ACT Expo in Long Beach is just next week, and Move America in Austin next month. The ACT Expo is actually 2 short miles from our facility, so we can even coordinate a visit and a live demo of our battery testing capabilities. And for Move America, Kenny, one of our engineers, will be speaking more on the opportunities in second life batteries. Aside from our 50% discount link, we have a few free passes we can give away too. So please reach out if you're interested. Next slide, please. Lastly, if you'd like to get more information, like the recording I mentioned earlier, we have 3 pre-recorded technical presentations that are available on demand. One of them would be a great technical complement to my presentation today. You can request them by going to our website. The QR code on the screen will take you there now. From there, just navigate to what we do and click on our technology. You can also find a virtual demo on our site under About Us. And lastly, you can monitor our progress by following us on social media or by subscribing to our newsletter. Next slide, please. In closing, understanding the used battery's state of health is critical to enabling the circular economy. Rejoule offers a faster way to qualify these batteries, and we have the capabilities to test cells and modules now. We're scaling up our technology to test battery packs in vehicle, and we're seeking partners for proof of concept projects to support us on this effort, so please reach out to us. We'd love to help you maximize the value of your EV batteries. Thank you.